Okay, on this next one, I'm starting out with x squared minus 5x equals 36. I see that it's quadratic, which means I have an x squared, no x cubes, no x to the fifth, nothing like that. That's a quadratic if it starts with x squared. Well, it doesn't have to start with it. If the biggest power of x is squared. Now, since it's a quadratic, I want to get everything on one side and 0 on the other side, and I do that by moving the 36, subtracting 36 from both sides. So this is what I'm trying to solve. So I need two numbers that multiply to give me negative 36 and add to give me negative 5. And the sign really, really matters. You notice this is a lot like the last one we did, but the signs are slightly different. So those two numbers have to be negative 9 and positive 4. Negative 9 times positive 4 equals negative 36. Negative 9 plus positive 4 equals negative 5. So I write negative 9. If it's negative 9, that tells you to put a minus. If it's positive 4, you're putting a plus. So it's just like x, negative 9, x, positive 4. So this is the factored form of this. If I multiplied this out using FOIL, I would get this. So factoring is like unfoiling, okay? So now I take each one of those factors and I solve it by setting it equal to 0. Negative 4 and 9 are my solutions. That's fine as long as x isn't supposed to represent a length. If there are lengths represented by the values of x, go back and plug in and make sure you wouldn't end up with negative lengths. Like if it were, let's say it were negative 5x, that would still work if my length said negative 5x, because negative 5 times negative 4 would give me a positive. This one wouldn't work in that case. But you just have to look at your situation and make sure it's okay for x to be a negative, and if it's not, you throw that one out.